We know how to train a model in SageMaker. Now let's do something a little bit different. So let's imagine that when we run this pipeline, we don't know exactly what the source data will look like. Like, of course, when we're building the pipeline, we already created a model, we trained it, we evaluated it. Like, we know exactly what is the configuration that we need to get the best model out for the data set that we have during development. But as we go out there, we deploy our pipeline, we collect more data, well, we have no idea whether that pipeline will produce the best possible model. So one thing that we can do is, instead of using a training step as part of our pipeline, we could use a tuning step. Here is the difference. The training step uses a set of hyperparameters and trains one model. The tuning step instead is going to use a different or multiple sets of hyperparameters and train several models. And then it will compare each one of those models to select the best possible model for our use case. That sounds like a super good idea. So here is the code for this session. And let me go to the website so I can make this image a little bit bigger. Here it is. This is what this is going to look like. And if you remember in session 4, this is the same diagram that we had, but instead of using a training model, now we're using a tuning step. So we had our pre-processing step. We're going to get the train and validation data. Those are outputs of the pre-processing step. And we're going to use those outputs as inputs for the tuning step. The tuning step is not just going to train a single model. Instead, the tuning step will explore different configuration settings to train multiple models, and we have the ability to control how many models we want to train. And then we are going to get the best model as the output from this step. So that's what you see here. Best model is going to come out of the tuning step into the next step that we will build in a future session, the evaluation step. This is what we want to build. Let's see how we can do this. First of all, I'm going to create a variable here for my session. Let me just execute this. So I'm going to create this variable, which is called useTuningStep. And useTuningStep, I can change it to true or to false, depending on whether I want to use tuning. One thing to notice, though, is that keep in mind that the tuning step does not work in local mode. If you're working on local mode, tuning does not work. It only works in the cloud. I'm going to set this to true. So I'm going to say, yes, we want to use the tuning step. So please set this to true. And again, this is just a flag for me here so I can switch it back and forth. And now let's start configuring the tuning step. Now, as a reminder, when we created the pre-processing step, we required a processor and then the processing step. For training a model, we required an estimator and then the training step. Here, for the tuning step, we need to create a class, or we need to use a class, a concept that's called a tuner, that is going to specify the configuration for our tuning step. For those of you who are familiar with machine learning terminology, tuning obviously behind the scenes is just going to run what we call a hyperparameter tuning job. Hyperparameter is the word that we use to refer to configuration settings, right? So when we're training, let's say, a neural network, every single setting that you can change, that you can control, those we call hyperparameters. I don't know why we came up with that word. We should have called them settings, but anyway, we call them hyperparameters. A hyperparameter tuning job, what it does is it generates different sets of settings. So it computes what would be good settings for this model. We train a new model with that set of settings, and then we compare all of the models to just pick the best one. The whole explanation of how I configure the tuner is right here, but I'm gonna go line by line so we understand what's happening. I'm using the hyperparameter tuner class is a class offered by SageMaker in their Python SDK. The first parameter is which is the estimator that we're going to use. What estimator? And we created the estimator before in session 4. This hyperparameter tuning job behind the scenes is just going to use the same training job. The only difference is that the tuning job is going to run those training jobs using different parameters or different settings, but it's the same training job. That's why I'm passing the estimator. This is the estimator, not the one that we created using a custom Docker image to run Keras 3. This is the previously created estimator in session 4 that uses TensorFlow. So this is our TensorFlow estimator. As you can see here, when I hover over it, it says this is a TensorFlow estimator. Now, what is the objective metric name? In order to select the best model, what is the metric that I'm going to use to determine which one is the best model? What am I looking at? And in our case, we're going to be looking at the validation accuracy, and that is the name of that setting. So we're going to be looking at the validation accuracy, not a setting. That's not a setting. It's just a metric. We're going to be looking at the validation accuracy, and we want the model with the highest validation accuracy to be the best model. That is why the objective type is maximize, because we want the highest validation accuracy. For example, if we were using the validation loss as the metric, as the objective metric, then we will have to set the objective type to minimize, because the lower the loss, the better the model. Cool. These two should be clear now. What are the set of settings that we want to explore? What are the set of hyperparameters that we are going to explore? In my example here, I want to explore epochs. That's it. So I'm gonna be exploring the space of going from 10 epochs minimum to 50 epochs maximum. So that is the space that I want this tuning job to explore. What do I mean by exploring that space? Well, depending on the algorithm, the strategy that this tuning job is going to use, and depending on the number of training jobs that this tuning job is going to run, the job internally, from the space of parameters, it will select multiple values for those parameters, and then we'll use those to run the training steps. In our case here, you will see that I want a maximum number of jobs of 3. I only want to run 3 jobs. What is going to happen is that my tuning job will select 3 different values for epochs. There are multiple strategies, and we are gonna talk about those, or we talked about those in the live sessions. The strategy that's behind this tuner is a Bayesian strategy. And again, I talked about those strategies in the live sessions. So we're gonna discuss a little bit of how those strategies work. But using that strategy, what matters here is that the tuning job is going to pick 3 values for epochs, and it's going to generate 3 training jobs, and it's going to compare the 3 models with those 3 different values and pick the best one. And the best one is defined by the highest validation accuracy. So metric definitions is what we already saw as part of the training job on session 4. If we go to session 4 and we look at the training step, remember that we had to define these metric definitions with what is the specification for SageMaker to read these values off of the logs that my training job prints. So if I wanted to capture the loss of the model, this is the regular expression that SageMaker has to use to read the loss from the logs that I print, right? If I wanted to capture like validation accuracy, well, this is the regular expression. So the same thing we have to do as part of the hyperparameter tuning job. Let me go there. You can see that in order for us to read the validation accuracy, I'm telling SageMaker, hey, just read the validation accuracy using this regular expression. If you ask me, I don't like it, but it's the way the tuning job works. I cannot complain too much. So yeah, that's my metric definition there. Then I'm specifying that I want maximum of 3 jobs. That's the number, the total number of training jobs that SageMaker is going to run. And 3 of those jobs, a maximum of 3 of those jobs will run in parallel. Now I'm gonna take this, I'm gonna create a very different tuner just to illustrate how this works, okay? So I'm gonna create a new cell, and I'm gonna just duplicate all of that code, okay? I'm gonna call it tuner 2. And I'm just going to set this configuration very different. So let's say we want to be looking at the training loss. The name of training loss is just loss. That's the metric that gets printed out when we train the model. Let's go really quick to the CloudWatch. I have these logs from my latest training job. So I'm gonna go to the logs, and you will see that in the logs, I print out the loss of the model. You can see every epoch. This is epoch 4 out of 50. And I print out the loss was 0.95 and the loss is 0.91. And you can see as I move forward, how that loss is going to start decreasing. The loss represents sort of like the error that the model has, like how many mistakes the model makes. Not the number, but it's just a measure of the number of mistakes that the model makes. I want to look at the loss, and the model with the lowest training loss, that's gonna be my best model. And then I'm gonna say the objective type is gonna have to be minimized. So I want to minimize that loss. Now, what are the hyperparameters that I'm going to look at? Well, I'm gonna look at epochs. I'm going to look at, let's say, the batch size. And the batch size is gonna be an integer parameter, and it's gonna go between 16 to maybe 64. And maybe I want to explore a third parameter here, which is the learning rate, or hyperparameter is the learning rate. And the learning rate is not gonna be an integer parameter, it's gonna be a continuous parameter. I have not imported this. You need to import it from this same line. I'm not gonna do it because I'm not gonna be running this code, but you get the idea. This is gonna be a continuous parameter because it's a float value. And I'm gonna explore it between 0.01 and 0.03. So these are the 3 hyperparameters that I want to explore. Then obviously I'm gonna need to specify the definition for all of those hyperparameters. So one of them is the loss, and I can capture it like this. That's how I capture the loss. Then the maximum number of jobs, let's say I want to run, I don't know, 20 jobs, and 3 of them are gonna be in parallel. So what is going to happen here is that now for every one of those jobs, SageMaker is going to pick a set of values for epochs, batch size, and learning rate. And it's gonna use that combination of values and train one model. And then it's gonna do that again for the second training job. And gonna keep doing that for 20 jobs in total. And at the end of running all of those 20 jobs, SageMaker is gonna decide which of those jobs is the best one. Is the one that we want, it produces the best model. And the best model is defined by the one with the lowest training loss, because that's the definition that we put here. And again, there is only gonna be 3 of those jobs that at any given time will run at the same time. If you remember, we have limited number of instances of one individual type that we can run at once. Some of you have like 10 instances, for example. You cannot run more than 10 instances at a time, or maybe 3 instances. So you can control that with this parameter here, this maximum number of parallel jobs. One more thing that is going to be important. These 3 hyperparameters that I'm configuring here, I need to find a way for SageMaker to indicate to my training script what is the value for those 3 parameters. So I'm gonna open my training script here really quick. This is the same script that we created in session 4. And remember that this training script expects epochs and expects the batch size, because we created those. We created the ability for this script to receive those 2 hyperparameters. If we go to session 4, and we look at the code here, when we defined our estimator, remember that our estimator expects those 2 hyperparameters. So we can change them from outside the estimator. That's great. Now in my new definition here on session 6 on my tuning job, I'm saying that I also want to pass learning rate. So for this to work, I need to modify my estimator. So I will need to go to my estimator here and add the learning rate here. And I will also need to go to my training script and allow the script to receive a learning rate. So that's how you make that possible. That's how you tell SageMaker, yes, I support that parameter or that hyperparameter. So if you have a new value for it, just send it over. So let's go back. Let's delete the code that I just added. What is the code? It's right here. We don't need this cell anymore. We're going to delete it. Let's just execute this cell. It says that estimator is not defined. Of course, it's not defined because I have not run this before. So I need to execute everything here. Let me just make sure that I have it here. Okay, yes. So I just need to execute everything up to this point, and that should do it for me. Okay, so I'm gonna execute everything. Let's keep going down here. After I configure my tuner, and when that executes, I'm just gonna run this line. But after I configure my tuner, then I need to configure my tuning step. But before I do that, I want you to just pay attention to this image here. This is what's gonna happen in SageMaker behind the scenes. SageMaker is going to create multiple training jobs depending on what is the number of maximum jobs. And notice that each training job is going to have a different set of hyperparameters, so a different combination of values. So SageMaker is going to run all of those training jobs in a cluster. SageMaker will take care of managing those jobs. When they finish, they will report what the metric is. It will take care of all of that. That's not a problem, very simple. Let me execute this now. Let me execute this now. Okay, all good. All right, so the next step is to set up the tuning step using the tuner that we just configured. So this looks exactly like the training step. It's the same thing. It's just using a tuning step instead of a training step. So you can see that the name here is going to be tune model. The inputs are exactly the same inputs that we passed to the training step. We have a train input, and we expect the training data to come from the pre-processing step output. We have a validation input, and we have a pipeline input. And it makes sense that the inputs are the same because behind the scenes, the tuning job is using exactly the same training job that we created before. It's just adding a layer before that training job to decide the parameters that is going to pass to all of those training jobs. That's it. But the channel should be the same. The data should be the same. Everything will be the same here. After configuring the tuning job, final step is just to configure the pipeline. Notice that here I'm passing the tune model to the pipeline. So not the train, but the tune. And this is gonna be session 6. So after running this, let me actually run these 2 cells. When I run it here, oh, you know what? This is in local mode. I'm going to show you what happens if I try to run this in local mode. So you get an idea. I'm going to set this to session 6, run this cell, and I should get an exception that says there was an error. A step type tuning is not supported in local mode. So that's what you will get if you try to run one of these steps in local mode that are not supported. Okay, so not a biggie, not a big deal. Let's go back to local mode, set it to false. Now let's go back to session 7. So I know we're working on session 6. I just go to session 7 to be next to the final cell, execute everything above. It's just gonna take a minute here, and then we can re-execute this and run it in the cloud or with local mode equals false. You know what? I already ran this. So let me show you the results from yesterday. You don't have to wait for me to run this because I already ran it. Plus, it's going to take a little bit of time anyway. So let's look for session 6. This is a successful run from yesterday. Look at this. This is pre-processed data and then the tune model. Again, what we're doing here is just replacing the training step by a tuning step. But here is the good thing. I'm going to show you. I'm going to go here to SageMaker. And within training, there is a hyperparameter tuning jobs section. So if I click there, you will see this is the hyperparameter tuning jobs that I have. Notice that it says this is the name of the job, okay? The status, how many jobs were started and how many were completed, 3 out of 3. Creation time and how long it took. It only took 3 minutes to run 3 jobs because they run in parallel. Remember that the training job takes about 3 minutes to run. Well, it takes 3 minutes to run 3 because it's just, they run in parallel. So it's not, it's really quick. I'm gonna click on one of these, and within this tuning job, if you scroll down, it says, what are the training jobs that run? And you see here the name of the 3 training jobs that run. The status, the final objective metric value. This is the validation accuracy. 0.88, so 88% accurate this model, 82% accurate this model, and 80% accurate this model. These are my final validation accuracy values. If you go to scroll up, best training job, let's click there, and you get that this is the best training job. Validation accuracy was the objective metric, and the value was 88%. That was the best training job. And you can see here that number of epochs was 46. So by passing 46 epochs, I was able to get the best value. And we only tried 3 values. So let's go back. Let's see training jobs. Let's see if we can see what the values were. Well, I guess, I don't know if they just tell me here what the values are, or I have to go to each. I might need to go under each configuration to see what the values are. So this is the best one, which is 46. So let's just open another training job. By the way, this is the best one. Let's open the 82%. So if I go inside the 82% and I look at the hyperparameters, what are they? Here it is. The number of epochs was 32. So for this one, SageMaker decided to try a value of 32 for epochs, and the final evaluation validation accuracy was 0.82. And well, you can do the same thing by just going back to the other job. If I click on this one here and I go down, this one SageMaker tried 28. So SageMaker decided to try 28, 32, and 46. And the 46 one was the best one. Cool, awesome. So that looks good. I think I should be able to get the same information here from within Studio. Look at this. When I click on the overview, it tells me that the top training job was this one with 0.88%. You can see it there. There is a button there to see the training job. Then 82, then 80. You get the settings if you want to just review. Look at the strategy that it used. There are multiple strategies. Again, like I mentioned, we're going to talk about that in the live sessions. This is the Bayesian strategy. You can also use random, or you can also use like a grid search. Bayesian is the one that's smartest. That's the one that I'm using here by default. 3 number of training jobs, 3 number of parallel jobs. Going back to the code, clicking here or executing this cell. Awesome. Let's go back to the running. Let's run this now. And now that should be running exactly. So if I go back here online and I go to session 6 pipeline, you see that this execution is now running. And it's rerunning everything because I've made several changes throughout the script here. That's what is running everything. This finalizes the tuning session. The next session, we're going to be talking about evaluating the model. So I'll see you then.